Okay, let us do this problem. This is an easy problem already asked in J, this kind of concept. So you can use this problem to solve many other problem of the same kind. So let us just draw the diagram and then we'll discuss what the problem says. So do fast please. Tea is also very important in life. Sometimes you have a good tea, sometimes we don't have good tea. Very few times we have a good tea, you know. I don't know how they make tea. Sometimes I make the tea, it becomes perfect. But sometimes when I make, it does not become good. And this is again by chance. I don't know exactly which time it will be good and what time it will be bad. Even I don't know the ratio of... there is no fixed ratio, I think. It also depends upon mood, how you are making the tea. It also depends upon environment, everything. And when you are taking the tea, that is also important part. If you are very tired, in that case you will feel more relaxed. Okay, so you have done this diagram. Okay, let me discuss what this problem says. So I have a thin wire. So this thin wire, this has a positive charge. And the total positive charge over thin wire is Q. So this is the shape of ring and radius of this ring is R. And there is a charge, same positive in nature, is placed at the center of this circle or center of the ring. Now you see, as soon as you put a charge here, now there will be repulsion between these two. So this will try, so ring will try to stretch. It will be in tension. Are you getting or not? So there is a, so you will see there is a pressure kind of thing. You see here, everywhere there is a force because of Q1, Q2 by 4 pi epsilon naught R square. There is a charge and there is a charge, so there is a force, there is a charge, there is a charge, so there is a repulsion. So everywhere you have a repulsion, and that's why ring will try to pull apart. So the ring will have a tension. Ring is not a simple ring, it's not a relaxed ring, it is a ring in a tension. You have to find what is the tension in the ring. That is the important part. Let me give you a hint. What you will do is, you take a small section of ring d theta, find the charge, and then you take the total forces, component of total forces, and equate with the forces due to repulsion, that is the Coulombian repulsion force, and forces due to tension. You will find the answer. Let me give some time. You do this one. This is a easy problem. You can do this one. So let us take a break and then do this problem for 3-4 minutes. I am waiting for your answer. Maybe some of you maybe give me the answer. At least one person in the class should be able to give the right answer, because at least one or two must be able to do. Okay, now let us discuss the solution of this question. If you have done some attempt, so let us see what I want to say. Let us say this, take this part of this ring. So this part of the ring, if I consider, this is my center. So this total angle is d theta. So I am considering a part that has a d theta angle. So this becomes d theta, so symmetrical part. So this is d theta by 2. Again this is d theta by 2. So half. This side you have d theta by 2. This side also you have d theta by 2. Now if you see this section basically other part of the ring will try to pull this part. So there is a tension. This tension is coming from where? Other part of the ring. So if you see here, so this part of the ring is basically pulled by the other part of the ring. So this part of ring is basically pulling this ring this side. This point of this ring is pulling this ring this side. So you have a force in this direction, tension T, and here also you will have a tension T, because these two tension has to be equal, because the ring is in rest. So total force equals to mass into acceleration. Acceleration is 0. So total force, you see at each point you cannot have a tension that can change, because I have only these points, these masses are in rest. So that if you take any point, so total force this side, total force this side has to be balanced. So at any point tension can't vary. So at this point if tension is T, this point also T, this point also T, so finally also T. You see in some cases this tension cannot be fixed. there is a case when you have a friction forces. I cannot discuss it here. Okay, now go to the problem. So I have a tension this side, I have a tension this side. This tension will have a component along x direction, this tension will have a component along y direction. This will also have a tension component along x direction. This will have a component in y direction. You see, this component and this component will cancel to each other. You have a resultant component in downward direction. And this resultant component will be basically balanced by electric force. Now let us see, first find what is the charge on this section. So there is a positive charge. I can find, so in 2 pi angle there is a total charge q. So in one angle this is q by 2 pi charge. So in d theta angle I have a charge that is q by 2 pi into d theta. So this is the charge on the section I have considered. Let us make this section once again and then we will discuss. Make this section again. So if you see this section, there is a tension, this side also tension, this angle is d theta by 2. Now this line perpendicular to this line perpendicular to this line. So this angle has to be d theta by 2 because angle between line is equals to angle between perpendicular upon this line. This is perpendicular. Upon this line, this is perpendicular. So this angle is d theta by 2. So this component is t cos d theta by 2. This side you have a component t sin d theta by 2. Again same thing, this side you will have t cos d theta by and t sin d theta by 2. So total force downward, so in this direction these forces will cancel out. So in downward direction total force will be 2t sin d theta by 2. So 2t sin d theta by 2, if the sin theta is d theta is very small, sin theta can be written as d theta by 2. So this becomes t d theta. So this is the total force on the ring. So this is the vertical downward direction. So this force t d theta is acting basically vertically downward. So let me just wait for some time so that you can copy. Now let us calculate the repulsive force. Now there is a ring. This will also have a repulsive force. Now this ring is so small. I can assume this ring is very small. So I will have a force Q1 Q2 by 4 pi epsilon r square that will directly go in this direction. I can assume this ring size is so small. So due to this charge, this force is directly along this direction. And this force will be magnitude wise Q1 Q2 by 4 pi epsilon r square. So this charge, center charge is Q naught. And this charge dq we have calculated. So this is dq, so q1 q2 and by 4 pi epsilon r square, and then this has to be equals to t d theta. So if I place it here, t d theta is equals to this force. If you solve for t, you will get this answer. Okay, so if you are not able to write, just make a pause on your computer and then you write. Okay, so we finish this problem here. What we have learned what is the mechanism of stretching a string, how to find out the force in a string. The important point here we have to take the elemental part of a ring, d theta part, and then I have to consider the forces acting on the elemental part of a string, elemental part of ring. The same kind of question we will do again sometime later. In that case also, you have to take elemental part, d theta part, and then you have to analyze the forces acting on d theta. So small d theta, what are the forces that is acting there? So this is all about this problem. So we will discuss the next problem.